So I'm going to change it today to a red hat. So tonight you can call me JSON, or Jason. Okay, so let's continue. So Luke was going through about the ERC20 interface. ERC20 is quite interesting, and when I first looked at it, it took me a while to understand it, but now I've understood it. It is very powerful, and I'm quite amazed at the people who put together the ERC20 standard, put it together. So there's some very powerful features there that allow you to just create, it's like the stock exchange, the Ethereum blockchain, where if you want to issue a new BHP share, you want to create your own version of BHP or NAB or anything, you just write a contract. And the contract, as long as you specify the right parameters, just bring it up, that's an ERC standard there. So what it says here, and you guys can't see that, I'll zoom in a bit. Okay, what you will see is that there is a function called total supply that gives you the total amount of these tokens. It could be a BHP share, NAB share, whatever. The blockchain is like the ASX, except that everyone owns it. If you want to mine the blockchain, you can set up your GPU and RX 480 on a computer, connect it to the blockchain, and you are part of the network. So it's not centralized in the ASX, but anyone who participates is part of it. It can't be taken down easily, and if you want to issue your own shares, it's not really shares, and everyone heard about the Security Commission ruling on whether a token is a share or not, a security or not. You can just create your own smart contract and raise funds. There are several people in this room who have already raised funds. Lots of money, so if you need extra beer or pizza, that's the guy. There are quite a few people here who are also going to be raising capital in a few weeks, months, and they will be programming it to the ERC20 standard. So one of the nice things about the ERC20 standard is that you can then build upon it. One of the things that has been built is this really great site called Crypto Derivatives Market. And all this stuff, and I'll show you a bit of the relevant code in a moment. It's going to be taken down probably soon because of the SEC ruling that some of the tokens are securities, and if they're securities, then any exchanges that exchange those will have to go through their compliance and talk to them, and I don't want to do that. I like it. With this exchange, you can put up as many tokens as you want, with as much value as you want, and it's all just transferred in one atomic transaction. So you send ethers to it, you'll get an equivalent number of tokens back. So it's just like going to the ASX, except it's open, and sending your money directly to it, and you get 500 BHP shares. It's all immediate. No one's stopping you from setting the amounts and limits. You can do it without permission. So these are the sorts of trades that have happened on the crypto derivatives market. About $34 million Aussie dollars over the last 7 months, or since about November. And this is what it looks like, where you can have tokens for sale. There's 7,350 Ethereum Movie Venture tokens being sold here at a price of 0.002 ethers. And you can send as many ethers as will buy that token. And if there's any spare change, it will be sent back to your address. And this is done through very little amount of code. This is a transaction here. That's it. Someone sent an account, this account, C5, B9, sent 4 ethers. to the exchange contract. And in return, 2,000 Ethereum Movie Venture tokens were sent back automatically to that account. So you don't have to ask for permission, you just do it. You've got a token that you want to sell, just put it on, state the price, and someone else will come. Maybe, maybe not. If it's too high, it doesn't sell. And just buy it. And this is all made possible with ERC20. So this is the token trader factory that runs the crypto derivatives market. And this is the core of it. There is an asset, and the asset is an address that points to your token contract. There's a price to buy, price to sell, and there's no floating point numbers in Ethereum at the moment. So the calculations are done on integers. So the buy price or the sell price is that number there, the buy price, divided by the units. So using that, you can have fractions. And if you are buying some tokens, you send ethers, and the ethers will be represented in message value. And you divide it by the sell price, do some calculations, and notice this little thing here, ERC20. And that ERC20 interface, that's this little bit of code, handle any tokens. So if you were to list your own tokens, this contract will handle it. That's the power of the ERC20 interface. And it goes through and works out how much change it should give you back. And if the change is greater than 0, send back the change. And then transfer the tokens to your account. So, tokens, where are they generated from? A lot of them are generated in the best use case for Ethereum at the moment, which is crowd sales. It's a bit wonky, the whole crowd sale structure, because everyone who's trying to do a crowd sale is trying to classify them as not securities. So there are some crazy things of registering a company in Singapore, and you can't sell to the US citizens, you can't sell to Singaporean citizens, and this is all to avoid the regulations. The ERC20 and crowd sale contracts allow people with good ideas to very quickly, easily raise funds. If the idea is good, raises more funds, and get capital and try to build the idea into the product and hopefully make the blockchain a better place. A lot of these are blockchain-based projects. So going through the ERC20 contract, you need to have a record of what each account holds, and that's this mapping. So simple. All it is this is your account, the Ethereum account, and this is the number of tokens you hold. And when you want to transfer your tokens to another account, that's all it is. Transfer. And you transfer it too. And it just goes through, it does some checks, and it says the balance of your account goes down by an amount, balance of the other account goes up by another amount. Pretty simple. And this is a transfer from. A transfer from is like a checkbook where you authorize someone to spend some money on your behalf, and then that person can use it and spend it and send it to different accounts. And this is one of the use cases that the crypto derivatives market contracts use. And this is where you approve someone to spend your money. And just to make it simple, there is that's an example account 0x1111, and that's a token balance of 100, and 22222, that's 200. When you do a transfer, all you're doing is just altering the balance here. So all these ERC20 contracts just hold a few bits of information there. Well, I don't know how many bits, 2 bits, times 2, 512 bits, to represent your share of the token, the token contract, how many tokens are issued, and you have a little share of it. So I'm going to now take you to a crowd sale contract. If you are interested in crowd sale contracts, there are quite a few on my GitHub. I have been writing crowd sale contracts to receive ethers, issue tokens, and auditing other people's crowd sale contracts. They are easy to build, but hard to get right. And someone said to me, it's like giving a laser to children. You're going to point it in your eyes, their eyes. You know, plane flying over, yes, that's pointing. So some of the stuff ups that come out from token contracts that don't work correctly. You have not quite token contracts, but smart contracts. Everyone heard about the parity multi-sig bug? Yeah. So that bug was pretty obvious if you have a look at it. And so a hacker stole $30 million equivalent of ethers. It probably took about less than a day to do that, 3 accounts. It could have done that in 5 minutes once they worked out what the bug was. But they took their time and only stole from 3 accounts, and the white hat hackers then stole 200 million and put it in their accounts, and they've now returned 95% of it to the original owners. So smart contracts, easy to write, hard to get right. This is the token contract, where the core of it, and I'll expand it a bit, is this function, and it's a default function, so it doesn't have a name, payable. And this function receives the money. You send an ether to a contract, which is where it comes, and that is your address. And it jumps into proxy payment. There's some checks. Is it after the start date? Is it before the end date? Is it above a minimum contribution amount? Is it above a maximum contribution amount? And this is so simple. This is the amount of ethers that you're sending, and you multiply it by the number. So if you are issuing 10,000 ethers, 10,000 tokens per ether, 10,000. Then you need to record it. And the recording is done in these balances. So it says your account has this number of tokens. The total supply has gone up by this number of tokens, the same number. And that line there says send the money to a secure wallet. And it's done. So the other bits that the token contract does, normally at the end, is it allocates any tokens to the contributee. It sends any token that the founders of the group, that crowdfunding, sends them some tokens. And they call it reserves. Some have 40%. And they're keeping quiet. Yeah, because you can issue, let's say, 100,000 tokens, and the company then keeps itself 40,000, something like that. That's like 40% qualified. And they keep the ethers, so they get 2 bites in the same cake. Yeah, double it. So token contracts, what can be built on it? So I've built a decentralized exchange. What's coming up? There's going to be thousands and thousands of token contracts. People will be issuing them for themselves potentially. Your Internet of Things, little devices, 100 million devices, your solar cells might issue tokens. I don't know. Your fridge might go out and need some milk, so it goes and converts its token into Woolies tokens, and the Woolies tokens is used to buy the milk, and the milk gets delivered to your fridge, and the fridge is happy. And what's happening in Ethereum? You got the basic level, smart contracts, ERC20. On top of ERC20, you currently have decentralized exchanges and other things coming around. On top of that, you'll see more and more things being built, so it's being layered up. It is a beautiful picture. Any questions?
Yeah, real quick.
Yeah.
You know, like how USA regulates securities, but if you build a decentralized exchange, I want to hear
You can't do much about.
Well, if you build a
should be fine.
decentralized exchange on Ethereum exchange.
So the question is, if you build a decentralized exchange on Ethereum, they can't do much about it. The Security Commission can't do much about it.
Well, it's a bit centralized because I run a website that shows all the rates that are being offered.
So the exchange itself is decentralized, but viewing the exchange is not so easy yet because it's all just code.
Yeah.
So Bocky still runs the website that views the exchange, which lands in a position.
The volume of tokens for your launch.
Yep.
What is the range, like, between the millions or the 100,000s? Like, what is optimized and works best? The liquidity of it. What's the best volume?
For the launch of a crowd sale contract.
Yeah.
So personally, I have only worked with the smaller ones. Some of them failed to raise funds.
But the number of tokens.
The number of tokens is all just relative.
Yeah.
The number doesn't really matter.
It's kind of a marketing question. You know, if your marketing spin is that I want tokens to seem really valuable, you might release 10 tokens at $13,000 each, right? But if you want a marketing spin to seem like, I know there was someone at SydEth Ethereum recently spoke about their crowd sale where they wanted to do 7.2 billion tokens because that's how many people there are in the world, right? Yeah, it's an interesting one. But the point is, the number of tokens you do is a marketing thing, and it's the price you set it at.
How is it regulated? It's not.
It's not, yeah.
And
So
the
far it's not.
regulators are looking at it, and I myself feel that they should not go too hard on it because there's a lot of people that are coming up with great ideas, and there's going to be more, and it's going to stifle that. But on the other hand, there are a lot of people who are happy to just send their money to any contract. They don't really, how many of you have read the terms of and conditions in a crowd sale when you have participated in? And how many have not read the terms and conditions?
Yeah, how many even read the white paper? That's a good question.
I briefly skipped it.
How is it going to scale?
I know when you've gone for an ICO, the gas you've got to use every buy,
Yeah.
stuffing, things down like that.
Yeah.
So that's one question. The other question, generally speaking, all these ERC 20 tokens, trying to, and so all the exchange of people are now doing to do.
Yeah.
I realise the gas price will stop the ultimate ceiling, but then sort of predict a throughput on the network.
Yeah.
So the question is, how does it scale? If everyone starts launching these things, how many can we fit into a block? And then when does gas price become so ridiculous that you can't even deal with it anymore?
So the nice thing about Ethereum is that your blocks will increase if you use increases. So there is a limit, a block gas limit that minus in specific. If the network starts sending more transactions that require more gas, the limit increases slowly. It will decrease again. Yeah. So there's an algorithm that does that.
Did anyone launch an ICO on Ethereum Classic?
Yes, that's true. Still developed.
Yeah, so the question was, did anyone launch an ICO on Ethereum Classic? And theirs was
Nexerin. The guy called Nexerin.
guy called Nexerin.
Yeah.
The believer.
Nexerin.
Yo.
No.
I just had a question.
This gentleman has been his hand up's been for a long time.
After SegWit 2x activates, Bitcoin can start issuing tokens. Thoughts on that?
Yeah, so the question was, after SegWit 2x activates, Bitcoin can start issuing tokens.
Does anyone care? Sorry.
Yeah, I mean, the Bitcoin can then do tokens, you're right. Is it better? It's so I can hear lots of things being yelled at me, such as, it's still not Turing complete, right?
Yeah, so Toshi made an election not to make it true complete, so one point was going to happen. So
Yeah.
that would be, it'd be interesting to try and get that through
Yeah.
in bit whatever
good answer. Basically, Satoshi made it non-Turing complete for a reason. It's limited. It's limited compared to Ethereum.
And the counter argument to that is that all blockchains are changing from what they were originally supposed to be, so that doesn't really matter.
Yeah.
But everything's changing based on how you can scale it.
Yeah, everything's and when we see the changes in Bitcoin actually come live, we'll make the decision. Yeah, James.
Does Rootstock make Bitcoin smart contracts Turing complete?
Does root stock make Bitcoin smart contracts Turing complete? I think that's kind of the purpose of it, but honestly, I don't know much about it. Cool.
How does ERC 23 fit?
ERC 223 or ERC 23 is quite interesting because some people have tried implementing it. So it's a standard where a token contract can send tokens to another contract, and that contract will know when it's received. What happened in one of these cases, one of the tokens, the crowd sales that we supposed to, not responsible for, but they implemented ERC 223. And what happened is their tokens got blocked in an exchange because the exchange were running smart contracts. The smart contracts they have to expect ERC 223 or ERC 223 tokens are just rejected. So that token can't go on that exchange.
Not a good idea for crowd sales, like maybe an internal function.
Yeah, probably not right yet. But as more and more of the infrastructure start accepting ERC 223, then it might become better.
So that question was about ERC 223, which is an extension to ERC 20 to make it a bit more modernized and understand what's coming. So if I accidentally send my tokens to a smart contract, and that smart contract's not set up to receive them, the transaction won't go through, plus a few other things.
Yeah.
Yeah, this guy, you had a question out for a while.
So it's kind of a scaling question as well. Is it more to do with price of executing these things? So my question is more around since there's a finite amount of Ethereum, and you're using Ethereum as gas, and if you wanted to use it for like every day-to-day action through smart contracts, isn't it going to become incredibly expensive?
Gas is decoupled from Ethereum for a reason, right? If Ethereum becomes ridiculously expensive because there's not enough around, the gas price reduces, right? And the gas price is set by anyone who authors the transaction that I spoke about. You get to choose your own gas price, right? So I can make my gas so cheap.
But only in a fraction of
No.
Ethereum. Right?
Yeah. So I specify my gas price compared to 1 ether, right? 1 gas is worth this much ether.
So the smallest amount would be 0.00001.
Yeah, so I can go down to 10 to the minus 18 ether, right?
You can send zero gas.
Yes, and you can actually send 0 gas.
But
Right.
whether your transaction gets accepted or not
Yeah.
depends on whether a miner will buy it.
Exactly. The miners then get to decide whether that's a good enough price for them and whether they'll accept your transaction. Right. So that's why gas exists, and it is decoupled from Ethereum through the gas price.
10 to the negative 18 sounds huge at the moment, but if everyone is using the network and
10
using it for like
10 to the 18 is really, really, really big.
yeah,
It doesn't sound that like it's real. Like
it is.
Bitcoin is 10 to the minus 9,
Yeah.
and we're fine with that at the moment. Bitcoin,
But you're not
10 to the minus
using it
18 is
for
not 9 times bigger,
Yeah,
right?
you
It's
don't
10
use-
to the 9 times bigger.
You don't use Bitcoin for microtransactions globally. Like,
I think you have to design computers with limits, right? There's a lot of examples of limits.
But exactly. What's going to happen with IOTA if it was actually taken by, if every person had 20 devices that use it?
So the question is basically,
You can always
yeah,
more, not dilute the percentage of all the holdings as potential solutions to some extent. You can always say, yes, here's our holdings, let's just shift investment more to most bank everyone's the same proportion of money supply. So you don't dilute levels to do that.
cool. This has been fun. I think it's time. Everyone's sort of staring at me with a bit of all right, I want a drink. Right, it's time to have a drink. Right, we're going to take 15 minutes. It's so rude and talk over the top of me. Yeah, it's nice. I can't do that. There we go.
Yeah, thank you. Get some claps. All right, guys, sit down. Shut up. That's enough. Networking's over. You get it again after Adrian shuts up. All right, I'd like to introduce you guys to Miss Doctor, not quite, almost Doctor Adrian Manning, who is a PhD in physics and also my co-founder of Sigma Prime. Knows a lot about stuff, and he's going to tell you where is all this going. Oh, take it away.
Okay, I'm supposed to start. Just as a quick estimate, how many people here know nothing about Ethereum and only came because the name sounds relatively cool? Apart from Luke's intro talk. Okay, so it's only about 4 or 5. So this talk that I'm going to give is a high-level overview of Ethereum, so it's not a technical talk, so hopefully everyone should be able to follow this. However, if there's any tech people in the audience that want to ask me questions, I'm happy to turn it into one, so as we go through, you can ask technical questions. But before I start, I just mainly wanted to talk about why I chose to give this particular talk as an overview of what Ethereum is. And the reason is that I've been to a number of these meetups, and a lot of the talks that I see are typically about what Ethereum is right now. There's not much discussion going on about what Ethereum's developing and what their actual end goal is. What is Ethereum going to be in 1 or 2 years? And that's not localized just to this. That's not localized just to this ETH meetup. Typically, in the dev space and in the community, there's not that much documentation about what Ethereum, what the dev guys are actually building right now, and what they're actually trying to solve with Ethereum. So I collected a few slides and sort of a quick 30-minute talk to try and let you guys know about what Ethereum is trying to do. So I've got 2 main objectives with this talk. The first one is that I want to try, when people ask you what is Ethereum, the typical, you're kind of inclined to say, oh, well, Ethereum is decentralized apps on a blockchain. We can have immutable code, we can put it on the blockchain, and it can run decentralized applications. I want to try and change that narrative into something more along the lines of Ethereum, it's the new internet. And I know that as I say that, there's a few tech people here that cringe over the new internet, because technically it's not the new internet, it's the new web. But that doesn't sound as good, right? If you say Ethereum, it's the new internet, then you usually get more people interested in what you have to say. Secondly is I want to try and impart at least some of my enthusiasm in this technology, and the way that I'm going to try and do that is to at least try and argue that the current internet is broken, we need something to fix it, and Ethereum is a way to do it. So hopefully if I achieve that task, the questions towards the end of this talk are going to be something along the lines of, what's the best exchange to buy Ethereum? But I suppose we'll see how we go. Okay, I guess, before I start, my name is Adrian, as these slides suggest. As Luke said, I finished a PhD in theoretical physics, and I've been drinking the blockchain Kool-Aid for more years than I can count, and it's probably a little bit too much because I've now given up on maths and physics, and now I'm a blockchain consultant. So, Ethereum, I think, is where it's at. As a blockchain consultant, I'm supposed to be blockchain agnostic, but Ethereum's not. Okay, so let's start. So, what is Ethereum? So, this is the kind of question that gets asked in these meetups all the time, and I've heard hundreds of different kinds of responses to this kind of thing, and I just want to have a one-slide kind of explanation of the common kinds of things that you'll hear when you ask this question. What is Ethereum? The first one is typically things, which is Luke is the culprit of doing, he did it today, is you start and you say, okay, look, there's a thing called a blockchain, and then there's Bitcoin. Bitcoin is the first one, it does money. And then people came along and were like, it's all open source, so we can fork this thing. So then people came along and they forked it, and they made Litecoin, and Litecoin's like a faster version of Bitcoin, and it also does money. And after a bit of time, people realized, well, wait a second, we can do a little bit more cool stuff with this blockchain things, and we made blockchain 2.0, and we can now put arbitrary code onto the blockchain. And then you have Ethereum, and Ethereum does arbitrary code, you have waves, you can tokenize things, and 100 of other different things. My beef with this explanation is you kind of put Ethereum into the box with every other cryptocurrency. It just looks like some other arbitrary cryptocurrency amongst all the others. But also, unlike Bitcoin, so you've got Bitcoin up here, Bitcoin does exactly what it's always planned to do. It deals with money and it looks after money. Ethereum hasn't even started to at least finish to do its what it's designed to do. What it's designed to do is still kind of abstract. So a lot of people liken Ethereum to maybe like a person, and if you were to do that, Ethereum is like in its toddler stage. It's not even close to maturity. The things that it's going to do in the next couple of years is going to be completely revolutionary, in my opinion. And that's why I don't really like the fact that you put this in the same bucket as Bitcoin and Litecoin, because they have no actual end goals. If you talk to some more tech kind of people, you might have some fancy words. I've heard it a little bit earlier today. You get things like Turing complete, right? Ethereum's a Turing complete thing. It's got a virtual machine. You might even hear people say things like, what is it? You generalize the opcodes in Bitcoin so that you have a Turing complete Ethereum virtual machine that DApps run on and all these kind of technical jargon, which is all true. You also have things like you've got decentralized programs, you've got programmable money as a slogan, unstoppable, immutable code, which is kind of controversial at this time. But all these kinds of things, they are true. And even if you go to the actual Ethereum website, and I grab this one off Ethereum.org, the Ethereum Foundation, their explanation of what Ethereum is, it's a decentralized platform that runs smart contracts, applications that run exactly as programmed without any possibility of downtime, censorship, fraud, or third-party interference. And that's what the Ethereum Foundation actually calls Ethereum. And all of these explanations, in my opinion, are unsatisfactory of what Ethereum is, which is why I'm going to give this talk. I think Ethereum is much, much more than this, and it's because of the goal that the developers have for it. And that's going to try and what I'm going to articulate throughout the talk. So, Ethereum, it's more than just dApps. In the dev or in the sort of the community, the Ethereum community, there's a coined frame called the Holy Trinity. And this is a unification of 3 different kinds of technologies. The first one is Ethereum, which is this logo, which hopefully everybody here at least has some understanding of what that is. The second one is Whisper. Whisper is a technology that's going to be built onto Ethereum, and essentially it's allowing communication between decentralized applications. So Ethereum is a network. You've got nodes connected across that network. There's more things apart from building a blockchain across those nodes and the interconnected things that you can do. One of them is communication. So if anyone knows Tor or the Onion router, you can do similar kind of things across that network, and that's what Whisper's aiming at doing. The third one is Swarm, and Swarm is a decentralized file storage system. You have to store large files and things onto that. So these are 3 technologies which together, when they unify, is called the Holy Trinity. And this plays an important role in what Ethereum is trying to develop. So the three major things is Ethereum, and in particular we're going to be looking at programmable money. That's the key element of what we're going to be using Ethereum in this Holy Trinity kind of section. The second one, Whisper, allows, as I was saying, encrypted or anonymous communication messages between dApps or nodes on the network. And Swarm, as I said, is distributed file storage. You can think of it as kind of like a decentralized Dropbox. Okay. So now I've got to have an argument. Essentially, it says the current internet is broken. The web is broken. We need to fix it. Before anyone runs and jumps out the window because all our internet's going to explode, you do actually. I'm sure if you check your phone, you will see that YouTube and everything is still working. It hasn't exploded. It is actually still kind of good. You've got like in your pocket, you can have the entire collection of humankind just in your pocket sitting there. So I mean, it's not all that bad. It's not entirely broken, but it's still kind of dodgy. And let me explain that by firstly talking about the generations of the web. So when the internet first came out, we had what a lot of people coined as Web 1.0, and the web was essentially a static collection of web kind of files. Like the servers that were serving you files were kind of like static web HTML pages. Users had very little kind of interaction with them. It's kind of like, imagine like brochures and things, come and buy all my stuff off this thing, but you never really could interact with it. This eventually progressed where users want to have more kind of input onto the current technologies on the current internet, and that's where we developed Web 2.0, and this is where we currently live. And in this system, you currently have users, they produce content, but they don't have massive servers or massive infrastructures to store that content, so they put that content onto giant, massive corporations like Facebook, Google, YouTube, etc. And those companies then distribute that content to you, put advertising on it, and they get paid for it. Okay, so now I need to argue this is bad. We need to fix this. This is not good. And there's 2 arguments I want to try to apply. First one, consider the scenario, and this is actually a true story, maybe you guys have actually experienced this as well. If you had a friend that's just had a baby, and 30 seconds, maybe not even 30 seconds, after that baby comes out of the womb, they take a photo and put it on Facebook. Has anyone seen that? Has anyone seen like yeah, there we go, I've got a few. I've got a few friends that have done this. right? And then not only a couple of days later or even a month later, they take photos of that baby in different outfits and they say, look at my baby, it does all this cool stuff. And then, a year later, it's like, look, it said its first words, these are its first words. Some people go to the extremes and they make the baby a Facebook account, and that baby's got a Facebook account, and it's like doing its thing, and it checks in and logs into places and all this kind of stuff. My concern with this is there's a new precedent of data collection. Like we can store more data than we've ever been able to before, and literally in 5 to 10 years, Facebook will own the data of this child or this baby literally 30 seconds after it came out of the room. Right? It'll know places that it's been. It knows the first words that it said. If you use Facebook chat, then it knows all the messages that it said across everywhere. I used to be a data analyst, and there's some scary things you can do with large data and a little bit of mathematics. And eventually in the new world, data is going to be power, and in the current Web 2.0, you've got a handful of giant conglomerates that own everybody's data. And now, some of you may be like, oh, I don't care, you can know what I say to my friend on Tuesday afternoon. I don't care, they can know everything about me, I'm not doing anything dodgy. Or some of you might also be like, well, I don't even have a Facebook account, so that doesn't even worry me. But how many of your friends have a Facebook account? How many of your friends talk about you? You can do data correlation. So regardless of whether you have an account or not, the data is being stored. It's being stored by a small conglomerate of a number of people. And in 5 to 10 years, that's a dangerous thing. I'm personally terrified of where that's going to go. So this is a broken system. Some people are like, okay, well, I still don't care about that. There's another argument I want to propose, and that is an economic one. So that usually, pushes or motivates people a little bit more because money's involved. The other one, it kind of goes like this. Everything that you download off the internet, it costs you money. You have to pay per bit, per kilobyte, per megabyte, right? Every time you download and go to a website on your phone, it costs you money. There's a statistic that something like 70 to 80% of the data that you download is advertising, right? So you are literally paying to look at advertising currently in this system. And let's say you went to a website to look at Luke's dog photos because he has really cool dogs. You go to that website, and typically Luke has posted that on Facebook, so you're on Facebook. Facebook is the one that's selling you the advertisements. They're the ones that get the money. Luke gets little to nothing, and it costs you money. So in this current system, you're paying for advertising. The content producer gets almost nothing, and the middlemen are there making all this money, right? So in an ideal world, you should be getting paid to look at advertising. Your attention is valuable. You should be getting paid. The person that creates the content should also be getting paid. So that is another argument to why I think Web 2.0 is broken and we need to change it. So there's currently, in my opinion, 2 strategies that we can do from now. One, we can acknowledge this. We can kind of sit there amongst all the fire and just be like, okay, this is fine, like 5 to 10 years, like we'll see what happens. Or there's a group of other people, and the reason I'm giving this talk at an Ethereum meetup, just as a bit of a spoiler, it has to do with Ethereum. These guys have come up with a better way of doing this. We can fix these problems using Ethereum. And now they've thought about it long and hard, and they've come up with an entire new framework about how we can fix Web 2.0. And they were really original, and they came up with a really clever name. It's called Web 3.0. Okay. So I know you're thinking, like, okay, cool, we've got a solution to all of these problems, but how does it work? Now, I'm glad you're thinking about that, because I've come up with a completely fictional, has nothing to do with real life stories, cartoon depiction of how we can solve this problem. And it starts with a person whose name is Adrian. And Adrian is a physicist. And he has written a paper, and it's titled Gravitational Waves from the Phase Transition of a Nonlinear Realized Electroweak Game Symmetry. Really interesting stuff there. So Adrian was like, okay, this is some really cool stuff. I need the entire world to go and see this really interesting paper about gravitational waves or something. And so what Adrian does is he goes, I know, I will go upstairs to my computer and I'll build a web server and I'll put it on the internet. So he does that. He builds his home web server at home and puts it on the internet. And 2 people a year go and view it and see the paper and always do it really well. There's no issues. Okay. But then Adrian's friend comes along, Paul. Paul has a series of cat photos. And he's like, I want to share this with the world also. Can we put this on your web server? I'm not sure. Absolutely. We can put the cat photos on the web server. But the second that I do, 100 billion million people also want to go and see all the cat photos, and my server explodes because it can't handle all the bandwidth. So essentially what I'm trying to summarize here is that popular content, I can't just store on my home server. So at this point, I've got two options. One, I can go and spend hundreds of thousands of dollars and I can build my own internal infrastructure, my giant server farms and all these kinds of things, which would be really cool, by the way. But unfortunately, Adrian is an underpaid physicist and doesn't have the money for that. The second option he's got, which is free, is he can go for free, put his cat photos onto Facebook or YouTube or Google or etc. cloud services, and then they will then the whole cycle repeats where it went to 2.0, they make money off my content and they get all of the data, they own the data, and they get all the money. What if there was some alternative option? Okay, so here's where Ethereum and Swarm come in. So, what I'm going to try to describe here is imagine Swarm. This is a network. All those little bulbs there are technically computers, but I'm going to refer to them as nodes for a technical reason. So each node, each node is interconnected to a number of other nodes, but they're not all, I can't connect from this guy all the way up to this guy, right? I have to go through a few of them. So let's consider the scenario where this is me, my computer is on this node over here, and I've got my physics paper thingy over on this node up here, like this guy. Here's where this guy is. Okay, so in Swarm, the way that this works is that I then go to the node that's nearest to me and I ask, I want to get that paper. And I'll get that paper, but I'll give you 1F to do it. So here's 1F, go and fetch me that paper. And that guy goes, okay, sure, I'll do that. But he then checks, he goes, I don't have that paper, but I know somebody who does. So he asks that guy and he goes, I'll send you 1F if you can go get me that paper. That guy doesn't have it, but the process essentially continues. He sends 1F until eventually it goes to the node that has it. The node that has it then has that 1F, he goes, I've got that 1F, sure, I'll keep that F and I'll send you back the paper. So the paper gets routed back to these nodes, back to me, I've got my paper, and the end result is the guy that actually held the content of the data gets the money, right? He got received, cost me money to get it, and then he got it. So this is all good, but with this example, Web 2.0 also worked quite satisfactory. So, what about with cats? Popular content that everybody wants to see, how does this process work with cats? Same kind of deal. I ask the node, here's 1F, go get me all the cats. And then he reroutes it, same as what we did before, and then it comes back to me. Now there's one key point, is that the nodes that the cat photos routed back through aren't dumb. They're clever. What they're going to do is, instead of just like getting the cat photo and deleting it, they're going to cache it. They're going to cache it locally, so they store their own copy of it, right? He's cached that cat thing on that node because it's popular. The reason he wants to do that is an economic one, and you'll see that in a second. So let's consider we've got 3 more guys that come along and they all want that cat photo. They no longer have to go up to this node all the way up at the end here because this guy's cached it. So he sends 1F to get the node. The node that cached it now receives 1F, and this guy who also wants to get the cat photo is now closer to go to this node than the one that's all the way further away. So he goes through that guy, and then that node that cached the popular content gets the 2F, and the third guy also gets him. So he's made 3F just from caching this content that somebody else had asked for a while ago. Hopefully you can see that this kind of incentivized structure will auto-scale with popular content. It scales inversely compared to traditional systems. And what I mean by that is that if you have a standard server, right, like let's say you've got a server and it's got Game of Thrones on it, and there's 100 million people who want to download that Game of Thrones from that one server. The more people that want to download it, the slower it will take for you to download it because the bandwidth is limited. Hopefully that makes sense. Get a few nods. Okay, cool, we got a few nods. Okay, in this scenario, the more popular content, the more nodes are going to store it, right? And the more nodes that are going to store it, that means there's more places for you to download. So instead of downloading Game of Thrones from one particular location over on the other side of the world, you can download it from all of your next door neighbors all at once. So in this case, as content becomes more popular, you get greater and greater bandwidth, which is the opposite effect of what happens in the traditional system. Okay, so back to my example, I now have an alternative. And Swarm, this example that I'm showing you here is almost, at the moment, it's actually free. You can put your content on there and it's free and it auto-scales. So I've got now one extra option. I don't have to go and put my content onto Facebook or YouTube or Google anymore. I can put it onto Swarm. It will auto-scale. If I have cats that 100 million people want to view, put it onto Ethereum, right, or on Swarm. It will auto-scale. The bandwidth is even better. It's a better system. I will own my content. I can then do advertising on top of that. Now, maybe some of you are like, okay, cool, that's really cool in theory, but what if I wanted to actually build this thing? And what I'm going to tell you right now is that this thing is available. You can do this right now. The talk that I'm giving is on Swarm right now. You can build a node on there and collect, it's just like that. You can go and ask other nodes to collect this talk. In fact, for the tech people in the room, what I've got is, this is a Geth node running, this is a Swarm node running, this is the latest Mist. The latest Mist supports Swarm. And this is Mist. This is the latest Mist. I wanted to just prove a point, so I made up a quick HTML web page with SydEth, and there's a thing called ENS for people in the room that know what that is, so I can put a domain name. So a domain name, like the normal internet, I can put a domain name for Swarm, and I went to put SydEth.f. Somebody in this room beat me to it. There it is. Who is it? Yeah, nice. So someone beat me to that domain name, so I came up with a better one. Let's see if I can type. Okay. So I regret not getting in there before you, or even making a video because I didn't think about it. So I've got Syd. I'll type left-handed. Syd. Ethereum. Regrets. And I regret not getting it. So this, right now, if I press enter, I'm going through the Swarm network to collect a HTML file or a web page. So it's the new internet, right? I get a web page, press enter, and this is I quickly made it so, and I'm not really a front-end dev. So anyway, SydEth on Swarm, I've actually literally, like this, look at that. I've essentially just done this. My computer right now is one of these blocks on the Swarm network, and I went and collected that HTML file from Swarm. So this thing is actually active right now. You don't have to put your content onto Facebook, you can now put it on Swarm. Okay, so there's a whole plethora of things that Ethereum is trying to develop, and I only just want to briefly mention a few of these before I finish. So firstly, there's ENS. ENS is the equivalent of DNS. I've seen some documentation in the communities where they talk about legacy DNS. As you know, it's called legacy DNS, so I decided to chuck that in there. So if you're interested in ENS, you can look up domains to get ENS. The other cool thing that these guys are developing is Swatch. I've heard of that GitHub thing, that's a gist from Victor. If you know Victor, he's working on Swarm. And what Swatch is doing is they can actually, through this network, you can do live multimedia streaming, which is actually kind of cool. You get redundancy because you can go through multiple nodes, you increase the bandwidth, and you can have adaptive bandwidth over adaptive transmission latency, which is particularly cool with Swatch. So you can actually have live streams with this kind of network. The other thing I briefly want to mention is BAT, the basic attention token. You can go to this website and learn about it. The reason I want to mention that is because they're trying to solve the advertising problem that I mentioned as a problem about 2.0. So if you own your own content through Swarm, you can use the BAT, you can use essentially BAT tokens to pay your users that look at advertising, and you can use that as to replace the whole broken advertising section of the internet. So there's even more than that. Ethereum's got a whole heap of things going on. I don't have the time to talk about all of them, so I just want to just outline the roadmap in case any of you guys haven't seen it. The first thing there was an Olympic testnet. People played around with some Ethereum that doesn't actually count as proper Ethereum. There was Frontier. Frontier is essentially allowed, it was just a GUI interface. Devs can play around with Ethereum, looking at the things that there was very minimal libraries on the EVM. We're only at Homestead, it's where we are now. We have a GUI interface, we've got Mist, we've got Parry, we've got some EVM stuff. What's coming in a couple of months is Metropolis. They're in testing at the moment. They're going to abstract away some of the key signing and stuff into smart contracts, which is going to be kind of cool. This is coming out soon. And then Serenity is this, fabled thing to solve all possible blockchain problems. And it's going to do sharding, and it's going to do proof of stake, and this thing. So anyway, what I'm trying to articulate here is Ethereum is only still beginning, right? We don't even know where it's going to be by the time it gets Serenity, and that's probably about a year and a half off. Okay, so hopefully a lot of that made sense. This talk is on Swarm, so if you want to go and get the slides there, you can kind of figure out how to get to Swarm. If you Google Swarm gateways, it's not so difficult. That's the address. Cool, thank you.
question.
No. AKA free consultant.
Sure.
So you said that the content provider gets paid, right? But in your example, if I put the cat photo up and then the guy who's closest to me takes it and then he gets paid 3ETH, I produced it, but he gets paid. So
So in that scenario, the money, the incentivization to keep the network stable, think of it as like torrents, right? You have torrents. If everybody can just download Game of Thrones and nobody sees it, it's an unhealthy network because people aren't incentivized to see it give to everybody else, right? So the part where I used the incentivization through money, it's called SWAT, actually, the Small Accounting Protocol, and it's incentivized to keep the network stable, as in you want people to upload as much as they download. So in that scenario, if you just had a node sitting on that network, it would automatically cache for you, you would just make money just by being a node on the network. So as long as you download as much as you upload, then you don't lose any money, you don't gain any money. In that scenario, I was just trying to show that it should always scale. In terms of making money from content though, because you would own that content, you could encrypt it, for example. This is just collecting data. So if you own that content, you could encrypt it, then when other people retrieved it, then you could have some kind of incentivized advertising on top of that. Yeah, so that money is to incentivize network health.
Isn't that the batch token?
Yeah. So the BAT token would be for advertising on top of the content that you own.
Oh,
Yeah. The BAT's designed for advertising.
IPFS versus Swarm, just quickly, like,
IPFS versus Swarm.
Okay, so IPF is much more developed, it's much more built, it's much more structured, it's got a larger user base. The technologies are almost identical, very similar. The arguments for Swarm versus IPFS is that the guys that have built the Swarm are Ethereum guys through. The money that's paying them is essentially through Ethereum. IPFS originally weren't going to be on the Ethereum blockchain, but then eventually moved onto it. So the main argument is essentially philosophy where these guys are heading.
I saw a lot of interesting shirts at DEF CON in China where they had IPFS and Ethereum better together. So, same.
So with private content, you can encrypt it, obviously, and allow it to be, in our scenario, we've got possibility of many viewers, but not simultaneous many viewers. This works in that case also. I'm not trying to load up the network. I just don't know who the next person is to get that content. There's no impediment to that.
Oh yeah. There was you just reminded me of a thing that you mentioned, but I'm not sure whether I answered your question. So you're concerned with you don't know who's accessing the content?
I know who needs to have access, and I've sent them the location of the primary file.
Okay, yeah.
And
I understand the question. I think I understand the question. So the problem is, I think you're trying to get at is how I know where the location is. The way that it kind of works is you get a file, you take the hash of it. That hash essentially represents it's kind of like an address or a location. So the nodes each have their own hash, and then there's a metric that measures distance, and there's a distance away from that hash. So because you know your node connected to you, and you know each of their hashes, there's a distance function given. So essentially you can tell which node is closer to you to that file if you know the file's hash. Yeah, and so from that you can figure out the nodes can figure out who's closer to them, and then eventually.
Our routing table.
Yeah, exactly. Yeah, that's right. So as long as they know the hash essentially gives them the address. Yeah.
Thank you.
Yeah.
Sorry, can you repeat the question?
When does the cache become invalid? If I'm caching files, when does it become an invalid file? Right? So technically, you can't delete anything on Swarm, so it's never really invalid in the sense that it's not better. Like its hash will always be there if a node stores it. But in terms of people not storing any cache, with Swarm you can specify the length or the amount of data you want to cache, and then you'll just cache the most recent things that come in that. And as people stop asking for that content, it'll kind of fade away. Well, so let's say you can your particular node stores 1 megabyte of data, and 10 megabytes of other content has come through. You just no longer cache that particular thing. So yeah, it will go out of existence from that node. But that's not to say other nodes around you don't have it.
So it's distributed. I guess it's probably anonymized as well. What's to stop people putting up like
So the question is, it's potentially anonymized as well. What's to stop people from putting up nefarious information like nuclear weapon things?
Yeah, so I'm just going to
Not much.
add in a little bit of information before answering that. In Metropolis, they're actually introducing a protocol where they mix Whisper in with Swarm, so it makes it even more anonymous. You can't even see the people going through all this kind of stuff. And to answer your question, nothing. Yeah, you can put whatever you want on it. You can put it encrypted. Yeah, maybe even in Dropbox, right? You can have nuclear weapons, encrypt that thing, put it on Dropbox, like, fine.
Yep, up the back.
If Web 3.0 is what you think, is what you think Ethereum will
Turn into.
3.0,
Yep.
my question is, how does that affect the price?
So how does Web 3.0 affect the price? Question on everybody's mind.
I have no idea. I'm not sure whether
Something to do with the moon.
Yeah.
Getting there.
Right, but yeah, I mean, so if you're talking about Swarm, in theory, people are saying like, oh, if you just have servers sitting on Swarm, then you're going to be making money, right? I just make Ethereum out of nothing, but that's kind of true. But it incentivizes your data storage, and then you have to have use. So ideally, I think the economics is that it's supposed to even out, level out, like everybody, as long as the network's stable, everyone uploads so much as they download, no one's really making any money. But I mean, anyone can speculate. I mean, if this thing becomes a new internet, you're like, oh, a new death, like, I don't know, I don't know the answer.
It's really hard.
Tal?
The internet's kind of cool because it's democratized, so all data is accessible to everyone. In this example, it seems like your Kim Kardashian or pictures of cats are going to be everywhere because people think they're going to make money off it. But the cool shit like your random article is not going to be accessible because, and you're going to have to pay lots and lots of money and ETH in order to get it. So actually, does this actually make the internet worse for that really cool tail shit that all of us want to see, but not Kim Kardashian crap that is going to be everywhere?
Yeah, that's a really good question. I was expecting somebody to ask that. They're currently working on this problem. Essentially, there's a number of protocols for storing data long term. But essentially, what it comes down to is somebody that wants their data to reliably be on the network, not just to be like, oh, somebody did, people haven't looked at it in the last couple of days, so it kind of disappears out of existence. If you want to ensure your data is on Swarm for 10 or 15 years, you can't just put it on there for free. You pay like essentially a subscription for particular nodes to store on the network for long term. And then the way that it works is like every 6 months or every 3 months you ping them, and then they have to show you a proof that they have that data. And if they do, then they can continue their subscription essentially. If they don't, they lose a deposit kind of thing. So there's a different mechanism for storing data long term. So for my article, instead of me putting it on for free, it would just cost me money.
Is it like a versioning system?
In this, not that I know of. If you want to change a file, you just change the hash, and the other things just disappear out of existence.
But if you did go for a previous version,
The versioning system would be, so every single file isn't so in a traditional file system, you see a file is represented by the folders that it's in and then its file name. You can change the version of that. In this case, the file itself is hashed, right? So the content of the file determines its location. The only way to version things is using ENS. So if you have an ENS address pointing to a file, well, you can update that to point to the new file. But each file exists at a location determined by the contents of the file. Yes, no version.
So if there's a super embarrassing photo of me which I was really happy to have, and now for some reason I'm not happy to have, it's going to exist everywhere and I can't get rid of it.
If it's on Swarm, it's there forever.
Yeah, I did that not an hour before. I put the wrong presentation. I put the source code of this presentation on you instead of not. And I'm like, oh, it's on there forever.
Yep.
So since we have asymmetrical storage in this type of mechanism here, are there benefits to being proof of existence mining?
Yeah. Well, as I was saying, if you want to store things long term, then you need to have proof of existence because essentially someone's paying you money to store the content, so you can't just not store it and then still receive the money. So they have a proof of storage, and the way that works is on local trees.
So all those ancient disk drives you can take back out of the
Exactly.
stacks and refire it up.
Yeah, and you can make some money by storing data.
Your disk drives and the new graphics cards.
Yep, in the blue shirt, behind my over.
Sorry?
I missed that.
So, repeat the question. How do you validate the data is correct? So the data is stored and its address is the hash of the data.
Yeah, for the long-term storage, right? You've got a massive file. You don't want to send the entire file. You just want to validate that they have it.
Credibility of the data. If you can hash it, and the hash is the same as the address of the data, then it has to be the same data. Wow. So how do users know the data is valid? Signatures, the same way they do on the internet right now. Yeah, it's the same problem. Wait.
I have a very small question.
Very small question.
Very small and very simple. Can we run this weekend in our own computers?
Can we run this weekend on our own computers?
Yes.
This laptop's running it now.
So what are the memory and CPU requirements? Is there everybody else can run it?
Okay, so the actual, the biggest constraint, get out. The biggest constraint at the moment is actually running a get node because it has to resolve. I found it.
Yeah, so it's doing 2 out of 16 gig, and it's not using a lot.
Yeah, no, but the biggest requirement is that's actually running a get node, and Swarm only uses get node to resolve ENS. Right? Swarm by itself is actually its own network, and it doesn't have a blockchain. Right? You don't have to store heaps of stuff. You just store stuff. It's very minimal. Well, I think you can do it on a Raspberry Pi.
With like massive data centers.
Sorry.
What we did is that massive data centers.
Yes.
Hosting basically everything.
Can we repeat the question?
Wouldn't it incentivize Facebook and Google to create large data centers? Is that right?
In the Swarm.
Yeah, in Swarm. Yeah, it incentivizes everybody to do that. Yeah. So the people that this is going to hurt is Facebook, Google, and the giant conglomerates that own all your data and make all the money off it.
If they enter the Swarm, wouldn't that pull traffic onto their massive data centers?
Yeah, that's fine, but they don't own it now.
Exactly.
You still own your own content. That's the whole point.
Not if my house is closer, right? Or if my house is closer to the data center.
Does that answer the question?
Would they still be able to like use data of like access or whatever to trace something back?
I think economically, like if you're saying if they stored all the data and then if they trace where the stuff's coming from, that's where Whisper comes involved. Whisper then anonymizes all that kind of transactions. Yeah, I think they're in a bit of trouble if it comes to fruition. Yeah.
So would this be a way to get around like whole data retention kind of stuff?
Would this be a way to get around cold data retention?
Like the whole data retention.
The data retention laws.
Yeah, all that kind of stuff.
Yes. Yeah, you can if you use it through Whisper, it's a VPN as well. Yeah, you can put arbitrary data on there, and other people can't know what it is. Yeah.
Doesn't this make big data like even more scary? Because now it's not just Facebook and Google who can track me and my stuff. It's like everyone.
No, but nobody can track your stuff, right? Because it's just like Tor, for example. You've got no one knows where the data's getting transferred across, and you own your own content, so it can be essentially completely anonymous. Yeah, I'm not, don't hold me to that. Yeah. I made it. I'm glad I got one comment on it. Thanks. So,
As everyone who's not, this is VB, Vitalik Buterin, who is the inventor of Ethereum. Yeah, that deserves a clap. That's him.
I made it for the content in last year. Okay, I think that's it.
I think we have one more over here.
Yeah, I think there's attack vectors in terms of timing analysis and that kind of stuff. So if you have enough nodes, you can watch traffic and try and figure out roughly where it's coming from. There are, I think Whisper is actively trying to solve that issue. It's the same kind of thing internally toward timing analysis, that kind of stuff.
Very, very hard to escape that.
Yeah, so there is that vector, but it's much better than what we currently have.
Validation of identity, isn't that feature in terms of actually determining the truth of the source, i.e. whether someone made it to pretend to be you instead of actually validating.
So it's about validating identities. Can someone pretend to be you?
Yeah, well, I mean, the whole point of reliability of data is that you know it's a certain source, so by losing the anonymity,
Yeah. So you can authenticate the source independently. You can still use digital signatures in the data itself. This is data storage mechanism. It's up to you to authenticate data in any case. Okay.
So things like SSL, will that work across this network? Or,
Will SSL work across this network?
I mean, do you have an encryption mechanism across?
So you have an encryption. You would encrypt the data. You encrypt the data before you store it on the network. When you retrieve the data, you decrypt the data.
Yeah, but again,
So
look, we said
the
it.
node, doesn't see the traffic that's going through it, but it only.
The node sees all the traffic that's going through it. But if I do traffic analysis on a network and I watch two nodes communicate, that communication is encrypted with an ephemeral key. So I can't sit there and do traffic analysis on the whole network just by watching it.
Right, but the node would know.
The individual node would know the contents of the file if it was not encrypted.
Yeah, again, think of it as like onion routing.
So transactions.
Yeah.
So if you're sending, I assume that you can send across the network as well. Can you post data through the network?
So Swarm is store file, retrieve file. It's not a live communications protocol. Whisper is a live communications protocol, and that's very similar to the onion routing protocol Tor. Yeah.
Any concerns raised to the Ethereum Foundation regarding illicit materials such as child pornography?
Are there any concerns raised in the Ethereum Foundation regarding illicit materials such as child pornography? You have to ask them. I'm sure there's a lot of concerns about that, but with great power comes great responsibility.
Researchers are losing sleep over this.
Researchers are losing sleep over this. Yeah, it's a big problem, right? You create a very powerful technology. Tor is a very powerful technology, and a lot of people use that for child pornography. That's a horrific use case of that technology. But is that worth removing the ability to have anonymous communication? That's a very political debate that I do not care to take on.
That was created by the US military.
And yes, the Tor was invented by the US Navy.
They needed more people to make it anonymous.
Yeah. Okay, I think that's the questions. All right, thanks guys. So I think we're going to get kicked out of here in about half an hour. We're Secret Crime. I just want to say thanks everyone for coming to SydEth. It's been fun. There's also the blockchain professionals meetup if anyone's interested as well.